Hi, it's Carly, and this video is on exponential expressions and equations. First, we'll look at simplifying single radical expressions. So here I have the expression cube root of 40a. Now I can break down 40 using a factor tree and get 2 times 2 times 2 times 5, which is 2 cubed times 5. So I'll replace 40 under the radical with 2 cubed times 5. Now I can pull out perfect cubes. 2 cubed is a perfect cube, so I can pull out 2. I can't do anything with 5 or a. So my answer is 2 times the cube root of 5a. Now, some common mistakes people might make when simplifying single radical expressions is not simplifying and taking out perfect cubes. So make sure that you do that. Next, we'll look at multiplying radical expressions. Now, you can only multiply if your index is the same, so that's a common mistake. You have to make sure that the index is the same before you start multiplying. So here we have 5 times the square root of 8x cubed y squared times 2 times the square root of 10xy cubed. Now here we can multiply because the index is 2 for both since we're finding the square roots. So first we'll multiply our coefficients, 5 times 2, which is 10. Now we can start multiplying under the radical. So 8 times 10 is 80. And remember, when multiplying we add our exponents. So x cubed times x is x to the 4th, and y squared times y cubed is y to the 5th. Now we want to break down our 80 using a factor tree, and that turns out to factor into 2 times 2 times 2 times 2 times 5, which is 2 to the 4th times 5. So we'll replace 80 under our radical with 2 to the 4th times 5. Now we can start pulling out our perfect squares. We can pull out 2 squared from 2 to the 4th. We can't pull out anything from 5, so that stays under the radical. We can pull out x squared from x to the 4th. And we can pull out y squared from y to the 5th, but we'll still have 1y under our radical. So if we simplify 2 squared to 4, we'll have 10 times 4 times x squared times y squared times the square root of 5y. And if we multiply 10 times 4, which is 40, we'll have 40 x squared y squared times the square root of 5y, and that's our answer. Next, we'll look at adding and subtracting radical expressions. Now you can only add and subtract if the index and the radicand are the same. Now, a simple mistake that a lot of people might make is just assuming that the radicand isn't the same, like in this expression, 6 times the cube root of 16y to the 4th plus 7 times the cube root of 2y. Now, although 16y to the 4th and 2y are different, we can simplify 16y to the 4th and end up with the same radicand. So we can do a factor tree of 16, and that factors into 2 times 2 times 2 times 2, which is 2 to the 4th. So then we'll have 6 times the cube root of 2 to the 4th, y to the 4th, plus 7 times the cube root of 2y. Now we can pull out our perfect cubes, so we can pull out 2 and y, and we'll still have 2y under the radical. So we'll have 12y times the cube root of 2y plus 7 times the cube root of 2y. So now we have the same radicand, so we can add or subtract. So here we'll add 12y plus 7. And another common mistake that a lot of people might make is trying to add our radicands together, but we can't add those together. It would just add 12y plus 7, and then it'll be times the cube root of 2y. Next, we'll look at changing radical expressions to expressions using fractional exponents. So if I have the radical expression cube root of x to the 4th, my index of 3 will become the denominator of my exponent, and my exponent of 4 will become the numerator. So it will become x to the power of 4 over 3. Now, a mistake people might make is when you have understood numbers. So for example, if you're finding the square root of x, don't forget there's an understood exponent of 1 and index of 2, so it would be x to the power of 1/2. Next, we'll look at solving equations with exponential expressions. So here we have the equation 3x plus 5 to the power of 1/2 equals 4. To cancel out that exponent of 1/2, we can square the entire expression. So if we square 3x plus 5 to the power of 1/2, we also have to square 4. That's a mistake people might make. Don't forget to do it to both sides of the equation. So since those two exponents cancel out, we'll have 3x plus 5 equals 4 squared, which is 16. So now we can solve this just like a regular equation. So we'll subtract 5 from both sides and get 3x equals 11, and then divide by 3 on both sides to solve for x. and it turns out that x equals 3.6 repeating. And since this is an equation, we can always plug our answer into the equation and make sure we have the correct answer.